Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns the chain rule. This guide describes how to use the chain rule to find the derivative of composite functions. It also shows you how to use your page in an efficient way when performing lengthy pieces of mathematics. Introduction. The most important skill when differentiating is being able to identify the form of the function you have to differentiate. Once you know the form of the function, you can choose an appropriate rule to differentiate it. Many complicated functions are created by combining basic functions in some way, usually by addition, subtraction, multiplication, division or composition. See study guide, more complicated functions, and the fact sheet, 5 basic functions. This guide is concerned with differentiating complicated functions which are made by composition of more basic functions. The rule used to differentiate composite functions is called the chain rule. To use the chain rule, you need to be able to differentiate basic functions. Methods to do this are discussed in the study guides Differentiating y equals ax to the power n and Differentiating basic functions. You should read these guides and familiarise yourself with the methods discussed in them before you continue with this guide. The results are summarised in the following table. Rule 1. Function k, where k is constant. Derivative 0. Rule 2. Function a multiplied by x, where a is constant. Derivative a. Rule 3. Function a multiplied by x to the power n. Derivative a multiplied by n multiplied by x to the power n minus 1. Rule 4. Function a multiplied by the sine of kx. Derivative a multiplied by k multiplied by the cosine of kx. Rule 5. Function a multiplied by the cosine of kx. Derivative minus a multiplied by k multiplied by the sine of kx. Rule 6. A multiplied by e to the power kx. Derivative a multiplied by k multiplied by e to the power kx. Rule 7. A multiplied by the natural logarithm of kx. Derivative a divided by x. Throughout this guide, these results will be referred to by the rule number in this table. If one function acts as the input to another, then the output is a composite function. In turn, the composite function can act as the input to another function, and so on, creating a chain of functions whose output is a composite function. The longer the chain, the more complicated the composite function. The differentiation rule for composite functions is called the chain rule. This guide will concentrate on the simplest case of composite functions which require only one use of the chain rule. The chain rule is given by if y equals f of g of x and you substitute u equals g of x so that y equals f of u, then, and this is the chain rule, dy by dx equals dy by du multiplied by du by dx. You will sometimes see the chain rule written as y dash of x equals g dash of x multiplied by f dash of g of x, which is the same but using the f dashed notation, explained in the study guide What is Differentiation? You can find the derivative of a function using the chain rule by following these steps. 1. Check the function you are differentiating as a composite function, y equals f of g of x. 2. Substitute u equals g of x so that y equals f of u. 3. Differentiate y equals f of u with respect to u to find dy by du. 4. Differentiate u equals g of x with respect to x to find du by dx. use dy by dx equals dy by du multiplied by du by dx to find the derivative. 6. Resubstitute u equals g of x to replace u so that u is not in your answer. Example. Differentiate y equals e to the power cos x. Step 1. This is a composite function where g of x equals cos x is the input into the exponential function. It is appropriate to use the chain rule to differentiate it. Step 2. A suitable substitution will be the power of the exponent, and so u equals cos x and y equals e to the u. Both of these functions can be differentiated using the table on page 1 of this guide. Step 3. As y equals e to the u, dy by du equals e to the u. This uses Rule 6. Step 4. As u equals cos x, du by dx equals minus sin x. This uses Rule 5. Step 5. Using the results from steps 3 and 4 in the chain rule gives dy by dx equals dy by du from step 3 multiplied by du by dx from step 4, which equals e to the u multiplied by minus sin x. Step 6. Resubstituting u equals cos x gives the derivative in terms of x only. Dy by dx equals minus e to the power cos x multiplied by sin x. Choosing a suitable substitution. The chain rule is an intricate piece of mathematics and requires the two-stage rule detailed above, similar to the power rule for differentiation. First, you must make sure that the function you are differentiating is made by the composition of two basic functions. If this is the case, you need to use the common mathematical tool of making a substitution. Here, you substitute a basic function, g of x, with u. You can think of this mathematically as making u equal g of x. There are some useful methods you can use to identify a suitable substitution to make for u. Use the bracketed part of functions. For example, in y equals sine of x squared, choose u equals x squared. In y equals the natural logarithm of 3x minus 2, choose u equals 3x minus 2. In y equals 4 minus 5x to the power 7 all to the power 8, choose u equals 4 minus 5x to the power 7, and so on. Use any mathematics under root signs. For example, in y equals the square root of 4 minus 3x squared, choose u equals 4 minus 3x squared. Use the powers of exponents. For example, in y equals e to the power x squared, choose u equals x squared. It is important that you can differentiate g of x with respect to x using the table on the first page of this guide. There is another effect of making the substitution. The original composition f of g of x can be written as f of u. If you have chosen a correct substitution, you should be able to differentiate f of u with respect to u, using the table on the first page of this guide. Arranging your page in longer pieces of mathematics. When you are doing more complicated pieces of mathematics, such as the chain rule, you may find it useful to divide your page vertically into an answer space, where your answer will be written, and an exploring space, where you can do any working and thinking which informs your answer. In chain rule calculations, the exploring space may contain a list of substitutions, the resulting derivatives, and any algebra you need to use in the calculus. In more complicated mathematics, the exploring space offers a vital place to play with ideas as you work towards your solution. Using this idea, you can arrange the mathematics in the first example in this guide as your answer space, your exploring space, separated by a line. Let's start in the answer space. You need to differentiate y equals e to the power cos x. Decide to use the chain rule. If u equals cosine of x, then y equals e to the power u. And the chain rule states dy by dx equals dy by du multiplied by du by dx. Now, into the exploring space. Dy by du equals e to the power u, using rule 6. Du by dx equals minus sin x, using rule 5. Back to the answer space. Dy by dx equals e to the power u multiplied by minus sin x, which equals minus e to the power u multiplied by sin x. Make a note, re-substitute u to give the answer in terms of x. So, dy by dx equals minus e to the power cos x multiplied by sin x. So when you differentiate y equals e to the power cos x, you get dy by dx equals minus e to the power cos x multiplied by sin x. Example. What is the derivative of y equals the sine of 3x minus 5? Step 1. This is a composite function where g of x equals 3x minus 5 is the input into the sine function. It is appropriate to use the chain rule to differentiate it. Step 2. A suitable substitution will be the bracketed part of the sine function, so u equals 3x minus 5 and y equals the sine of u. Both these functions can be differentiated using the table on page 1 of this guide. Step 3. As y equals the sine of u, dy by du equals the cosine of u, using rule 4. Step 4. As u equals 3x minus 5, du by dx equals 3, using rules 1 and 2 to differentiate minus 5 and 3x respectively. Step 5. Using the results from steps 3 and 4 in the chain rule gives dy by dx equals dy by du from step 3 multiplied by du by dx from step 4, which equals cosine of u multiplied by 3, which equals 3 cosine of u. Step 6. Resubstituting u equals 3x minus 5 gives dy by dx equals 3 multiplied by the cosine of 3x minus 5. This process can be depicted in the following way. Answer space, exploring space. Question. Differentiate y equals sine 3x minus 5. If u equals 3x minus 5, then y equals the sine of u. Chain rule, so dy by dx equals dy by du multiplied by du by dx. Dy by du equals cos u from rule 4. Du by dx equals 3 from rules 1 and 2. Substituting in, dy by dx equals cos of u multiplied by 3 equals 3 cos u. Resubstitute u to give the answer in terms of x. So dy by dx equals 3 cos 3x minus 5. So when you differentiate y equals sine of 3x minus 5, you get dy by dx equals 3 cos 3x minus 5. Example. Differentiate y equals the square root of 5 minus x squared. Step 1. Remember that the square root is the same as raising to the power a half, and so y equals the square root of 5 minus x squared equals 5 minus x squared to the power a half. This is a composite function where g of x is equal to 5 minus x squared as the input into the square root. It is appropriate to use the chain rule to differentiate it. Step 2. A suitable substitution would be the mathematics that is being square rooted. So u equals 5 minus x squared and y equals u to the power a half. Both these functions can be differentiated using the table on page 1 of this guide. Step 3. As y equals u to the power a half, dy by du equals u to the power minus a half divided by 2, which equals 1 divided by 2 multiplied by u to the power a half, using rule 3. Step 4. As u equals 5 minus x squared, du by dx equals minus 2x, using rule 3. Step 5. Using the results from steps 3 and 4 in the chain rule gives dy by dx equals dy by du from step 3 multiplied by du by dx from step 4. This equals 1 divided by 2 u to the half multiplied by minus 2 multiplied by x, which equals, after some algebra, minus x divided by u to the power a half. Step 6. Resubstituting u equals 5 minus x squared and replacing the root gives dy by dx equals minus x divided by 5 minus x squared all to the power a half, which equals minus x divided by the square root of 5 minus x squared. This process can be depicted in the following way. Answer space, exploring space. Question: differentiate y equals the square root of 5 minus x squared. If u equals 5 minus x squared, then y equals u to the power a half. So use the chain rule. Dy by dx equals dy by du multiplied by du by dx. Dy by du equals u to the power minus a half divided by 2, which equals 1 divided by 2 multiplied by u to the half from rule 3. Du by dx equals minus 2x, also from rule 3. Substituting into the chain rule, dy by dx equals 1 divided by 2 u to the power a half multiplied by minus 2x equals minus x divided by u to the half after cancelling down the 2. Resubstitute u to give the answer in terms of x. So dy by dx equals minus x divided by 5 minus x squared. So when you differentiate y equals the square root of 5 minus x squared, you get dy by dx equals minus x divided by the square root of 5 minus x squared after replacing the root. Further guidance and information. If you have any further questions about calculus or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of calculus, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.